A chemist wishes to separate and identify a mixture of substances using paper chromatography. The diagram shows the apparatus used in the solvent. The solvent is water. The solvent front is allowed to reach the top of the paper before the chemist removes the paper from the solvent. Which problem does this cause? The cause of the spot nearest to the bottom of the paper to catch up with the spot above it. This causes the spots nearest to the bottom of the kinda, but like I think the main problem is that this makes it impossible for us to calculate the RF value because we don't have the distance traveled by the solvent, right? We need that. That's in the denominator in our, right? If we don't have that, we can't calculate it, right? That's going to be an issue. So the answer is B. Let's take a look at C and D. This makes it impossible for us to use a locating agent. Well, you can still use it. Locating agent is just a spray that will react with the dyes and make them more visible, or if they're invisible, just visible, right? Not more. This results in a safety hazard caused by the solvent fumes. Well, the solvent fumes are water. So last time I checked, wasn't dangerous. Correct answer is B. In an experiment, 1 mole of powdered copper and 1 mole of powdered zinc. So you have 1 mole of powdered copper, right, which is just copper, and 1 mole of zinc present. Okay. Dilute acid containing 1 mole of acid is added to the flask. The flask is left until all the reactions, if any, are complete. So the acid will react with both and form zinc chloride and copper chloride, right? But I think they're trying to figure out that zinc will react first because zinc is a more reactive metal than copper. Zinc will react first and then copper will. So less of copper will be produced and more of zinc will be reacted, right? So that's the idea. So it's think of it as a displacement reaction. Okay, colorless neutral solution. Will the solution be neutral? Yes, it's zinc chloride and 1 mole of copper. I think we're on to something with A. Blue neutral solution, that means there's 50-50 zinc and copper. And blue neutral solution, yeah, I think it'll be more zinc being dissolved because it's more reactive. Blue, this is the opposite of it, so no. And acidic solution, like all the acid will be. Yeah, this is just silly. This is just the worst possible scenario, right? So I'm confident that A is the answer. Why? Because zinc will react more and turn into a solution, whereas copper won't because it's less reactive. A simple cell can be made using 2 different metals as electrodes and an aqueous solution as the electrolyte. Which statement about simple cells are correct? A greater voltage is produced using magnesium and silver. Yeah, different active electrodes, right? Using magnesium and silver than using magnesium and copper. So the greater the difference in reactivity, the greater the voltage, right? Because it'll fight just as hard. Magnesium, you have all your other elements, then you have copper, and at the bottom you have silver. So whatever the voltage is present over here, it'll be lesser than the voltage between these two, because this is way more reactive and this will cause a lot more electrons. This will react way more than the silver. So think of it as a tug of war where you have the most reactive element being the strongest tug of war player and the least reactive being the least strongest, right? Least reactive. So magnesium versus copper, magnesium and copper, magnesium will win definitely, but copper might still give magnesium some bit of fight compared to when magnesium fights with silver, because silver is even weaker than copper. So this is just, annihilation. Magnesium will overpower it. So similarly, what's going on over here is magnesium will easily overpower silver and create a stronger voltage difference. So this is correct. Electrolyte in an aqueous solution containing both positive and negative ions. Which, yeah, the electrolyte is an aqueous solution, yeah, containing both positive and negative ions. Yeah, that's true. That's what we see, right? The more reactive the metal will release electrons. That's also true. The more reactive elements will go from magnesium to turn into magnesium 2 plus and produce electrons. So all three statements are correct. The answer is A. Magnesium reacts with dilute sulfuric acid. 2 experiments were carried out. 24 grams of magnesium, so 1 mole of magnesium, easier to say, easier to think. 1 mole of magnesium was reacted with 100 centimeter cube, like 0.1 mole, right? Again, 1 mole, 50 of 0.2. 50 of 0.2, I think I'm gonna bet it's also 0.1 because you're doubling the moles but halving the volume, so the moles remain the same. But it's more concentrated, so the reaction will be faster but at the same height. That makes sense because the reactants and the products are the same amount. Which graph is correct? Okay. Which one is experiment? Okay, the dotted line is experiment 2. I think A is correct. A looks correct because they're both at the same, they're finishing at the same height, but experiment 2 will be faster because it's more concentrated, right? Okay, taking a look at B, this is wrong because it suggests the first experiment will be faster, which is wrong. And this suggests that they will produce different amounts. And this also suggests that they will produce different amounts because you're using the same ingredients for both of them, right? It's still all 1 mole versus 0.1 mole. That shouldn't change. Yeah? Okay, so the answer is A. Which statement is correct about aluminum and iron? Iron both form 2 plus ions. That's not true. Iron can form 2 plus ions and 3 plus ions, whereas aluminum can only form 3 plus ions. Transition elements will have multiple oxidation states or multiple charges, however, whatever you want to call these. Group 3 or any group elements will only have their standard charge depicted by the group that they're in. Both have amphoteric oxides. That's not true. That's not true. That is not true. Okay. Aluminum is amphoteric only in this case. Aluminum oxide is amphoteric. The manufacture of both metal involves the reduction of metal ions. Yeah, but what kind of a question is that? I think this might confuse people. But it's true. You see iron as iron 2, 3, right? And you react it with carbon to produce iron and carbon dioxide. If I were to balance it out, I think you need 2 over here, 4 over here, and what is this, 6? So 3 over here, 3 over here, something like that, right? I hope it's balanced. But this is reduction because iron is being reduced, right? On the other side, with what happens with aluminum is more reactive than carbon, so carbon can't do anything to displace it. So we use a good old electrolysis. We just melt it and we use electrolysis and forms aluminum and 3 seconds of oxygen. Yeah. Okay. And this is also reduction because aluminum is reducing. It has a charge of 3 plus, turning into 0. So oxidation number is reducing, or it's gaining electrons, both of which is reduction. It's correct. I think people might be confused that's with C, because the manufacturing system is different, the chemical reaction is different as well. That's not true. They are both normally manufactured by electrolysis. Well, we just talked about it. This is through carbon, and this is through electrolysis. The answer is C. All right, this is like a real question which should clear up a lot of issues people have with acid and bases and metals, like how things jumble up. Okay, so dilute hydrochloric, and like to note, you have to look at this question through a specific view, right? And dilute hydrochloric acid is added separately to samples of copper, copper oxide, and copper carbonate, which correctly shows whether copper chloride is produced. So essentially the reaction taking place. So over here, no reaction takes place, because the way to look at this problem is HCl and copper reaction as a metal displacement reaction. Is copper more reactive or less reactive than hydrogen? Copper is actually below hydrogen in the reactivity series and cannot displace hydrogen. So essentially this reaction does not take place. So that's a big no-no, right? Okay, copper oxide on the other hand will react because all metal oxides are either amphoteric or basic. So they will react with an acid. So this will react, and all carbonates react with an acid. And that's what they want you to do. This is how they want you to do this question. So the correct answer is D. Which ions are present when hydrochloric acid, which is HCl, has exactly neutralized aqueous sodium hydroxide? Aqueous sodium hydroxide is NaOH. And what's happening is HCl will react with NaOH to form NaCl, aqueous, and water aqueous. Well, water aqueous, nicely done. Liquid, right? And NaCl will actually be in the form of ions, Na plus and Cl minus. One common misunderstanding is people think H plus and OH ions are not in water. They don't exist in water. Like they'll naturally exist in water as well, right? So when it's water, those ions are there as well. So H plus ions and OH minus ions are there. So the correct answer is going to be A. Now, sometimes, like just to add to this question, let's say this reacted and the product was actually not aqueous but a solid. Solid implies that they're, like, we'll take NaCl as an example. Solid implies it's not aqueous and not in ionic form, but a giant, ionic substance in the beaker or wherever the reaction is taking place. So it's not part of the solution, it's not dissolved, and it's not in ion form, right? So then you'll only have H plus ions there and OH minus ions there if this was a solid, if this you were confident this is a solid. But it's not. It's aqueous. Sodium chloride, table salt, dissolves easily in water. Let's move on. Which experiment will result in the formation of white precipitate? Aqueous barium nitrate added to aqueous sodium chloride. This will not do anything too much. It's actually barium is testing for the sulfate ion, and when this forms, it's insoluble and forms a white precipitate. But that's what barium's used for. Yeah. Aqueous sodium carbonate reacting to calcium chloride, aqueous calcium chloride. And when they react, they're going to form calcium carbonate, right? And calcium carbonate does not dissolve in water at all. This is like marble, right? So it does not dissolve in water at all. So this will produce a white precipitate. Carbon dioxide passing through aqueous potassium chloride, that won't do anything at all. This is a salt and carbon dioxide. This reaction won't even take place. And dilute hydrochloric acid added to aqueous ammonia will form ammonium chloride, which is actually soluble in water. So the correct answer is B. The elements helium, argon, and neon are noble gases. Which statement is correct? All these elements have 8 electrons in their outer shell. That's true except for helium, which only has 2 electrons in its outer shell and still noble gas. Argon is used to react with impurities in the manufacturing of steel, while noble gases are very inert and do not react, so argon is not used. Helium is used in balloons. It is more. It's actually less dense. That's why it's used. Less dense. Lens dense. Lens dense. Lens dense. Okay, enough. Less dense. Neon is used in light bulbs to give it an inert atmosphere. That's true. If you had a light bulb and the wire was glowing hot, right? Yeah. So when the wire is glowing hot, what's going to happen if oxygen was here? It would react immediately. It'll burn in oxygen. So neon, when you use it over here, will give it, like, it's unreactive. It can glow as hot as possible without burning anything. It's kind of like putting sodium, in oil so it doesn't get in contact with any water, or it's a coating of oil. So think of it this way: it's a coating of an inert gas, so it's actually helping it not burn, right? That's the idea. So the correct answer is D. Which statement about group 1 metals are correct? They are hard compared to most other metals. It's the other way around. They're so soft that you can cut them with a knife, right? They're soft. You could have just taken a bite out of them, but like the water in your mouth might just make them combust, burn a lot, right? They form colored compounds. Actually, they do not. Transition elements will form colored compounds. They're all white compounds. They have high densities compared with most other elements. No. Like, why would it be different? It's like, and it's not even a thing that's like, no, they have actually lower densities versus other elements, like, because the higher the proton number, the more dense it is. So yeah, I mean, sodium is less dense than magnesium, probably, whereas potassium is more dense than magnesium. They only form ions with a charge, and that's true, right? That's easy. That's true, and the answer is D. Dry air is a mixture of gases, 99% nitrogen and oxygen. What is the main constituent of the remaining 1%? So the dry air won't have water really, right? Won't have water. And hydrogen, probably not, because it burns so easily, right? It burns easily, so any that was in the atmosphere would have burned long ago. Helium is inert, but have you ever heard of helium in the atmosphere? Also, if it was there in the atmosphere, it would have gone straight to the top of the atmosphere, right? And not be mixed, because it's so light, because what air balloons, right? They'll float, like they'll rise. So helium's out by just sheer logic, and argon is that 1%, right? So I didn't know argon was the correct answer, but dry air, so water's out. Hydrogen, because, like, it'll easily burn. So in any time people have had fire for like quite some time, so it would have all burned eventually. Helium is inert, but it'll rise away from the atmosphere, just using logic here. It won't mix too well with air. Argon's the only one left, so argon's the correct answer. The answer is A. When the alcohol of molecular formula C4H10 is oxidized, what is the molecular formula of the acid formed? So let's figure it out. You have 1, 2 carbon, 3 carbon, 4 carbon. Ha 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 ha. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I think this is the molecule they're talking about. H, 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 right? When it is oxidized, what's going to happen is this is going to turn into an acid. The alcohol bit turns into an acid. This would go away as well. And you'll have OH. What is the molecular formula here? C4O2H. Okay, you have 1, 2, 3, 4, 5, 6, 7, 8 H8. C is our answer. Which statement about polymers is correct? Nylon and terylene are produced by addition polymerization. It would be true if it was true, right? They're actually produced by condensation, right? Condensation. For addition, you need a double bond. Condensation. Over here, nylon would have an amide bond. Terylene is a polyester. Nylon and terylene both contain the amide linkage. Polyester, amide, like this would have it, but not both. This is a ester linkage. Simple sugars can be produced by hydrolyzing proteins. Amino acids are produced by hydrolyzing proteins. And yeah, starch contains the element carbon, hydrogen. Well, okay. We have our answer. And it's a silly question, and D is the correct answer.